going to be looking at lesson 2, and yesterday we looked at a lot of convection currents. Today we're still going to be looking at the wind, but today we're going to be looking more at specifically air masses and what they are. Mainly, 4 large bodies of air drift across the globe. When these air bodies are pushed together, the weather can change. Properties of air masses. Suppose your cousin just returned from a trip. You want to figure out where they went. When they show you the seashells they collected, you know that your cousins were at a beach. You can figure out where air has been too. The air's temperature and water vapor content can give you clues. Air that stays over an area for some time takes on properties of that area and becomes an air mass. An air mass is a large body of air with similar properties all through it. And right away in your notes, you're going to write down what an air mass is. So, an air mass is a large body of air with similar properties. Not exactly the same, but with similar. All through it. The most important properties, and we want to get this down too, so the most important properties are temperature and amount of water vapor. So temperature is going to play a big role, and the amount of water vapor. We're going to keep reading right here. It says an air mass keeps its original properties for a while it moves. So it doesn't mean that those properties can't change, but it's for a while as it moves. We're going to keep reading with kinds of masses. The picture on the right, so this globe, shows 4 kinds of air masses. Generally, the kind of weather you have at any time is because of the air mass in your area. If you are having several warm, clear days, the weather will remain that way until a new air mass comes into your area. Some kinds of weather usually happen only at the edges of air masses. Winds cause air masses to move. And right away, I'm going to get that into my notes, that it's the wind that's going to become really important. And we'll see in our next couple lessons when we get to see the different types of weather, how important that wind is. Some air masses are guided by the jet stream high above the ground. If the jet stream guides an air mass from Canada to the middle of the United States, northerly winds will probably bring cold, dry air. At the edge of this air mass, storms may occur. So you can see on here just the different way the arrows go and the different way those air masses come. So you can see that the continental tropical air brings warm air up because I know that it's warm since the red arrows, and then those northern winds are going to come down and bring cold air. And then in our notes for this one, I'm going to start with continental tropical air, and I just want to write a quick description. So I want to talk about what the air would be like. It'd be warm air, and fairly dry. Think of a desert when you think about the continental. So think desert. All right, and then we'll go back up to here. So the continental polar air, this air is cold and fairly dry. And it even says it's all the land during the or near the no, the poles, so we know that it's not very that it's not getting a lot of rain. The next one we go to is the maritime tropical air. It says that humid air has lots of moisture. So think about in the summertime, if it's really warm and humid, you might always feel like it's sweaty, and that's humidity. So over tropical oceans or rainforests, an air mass becomes warm and very humid because water can easily evaporate there. So it's going to be warm and humid. And then the last one we have is the maritime polar air. And it says even though the ocean near the poles is cold, water vapor evaporates into the air. An air mass forming over the poles is cold and moist. So it's going to be cold and wet. And so you see the connection here that you've got cold and dry, cold and wet, warm and humid, or warm and wet, and then warm and dry. So you kind of see those two connections there. I'm going to go on to the next page. Have you ever seen a line of clouds move from the horizon until it is overhead? What you have probably seen is the arrival of a front. A front is a boundary between two air masses. So I'm going to get that in my notes. A front is a boundary between two air masses. We're going to keep reading on. Most air masses move from west to east. So that'd be like over in California, over to like where Florida and New York are. So fronts have the same motion. A front gets its name from the kind of air that it moves into the area. A cold front brings colder air into an area. A warm front brings warmer air into an area. Sometimes a front does not move very much, or it moves back and forth over the same area. This kind of front is called a stationary front. So just looking at it, so nothing to fill in here, but a warm front brings warm weather, and a cold front brings colder weather. So those names make sense. And then a front that does not move very much or moves back and forth is a stationary front. And if you have heard of like a stationary bike, it's one that doesn't move, so that word makes sense. And then what I want you to do is just on the back side, your notes look like this. And we'll do the first one together. We'll do cold fronts together, and then warm fronts you can do on your own. So I want you to read through these captions on here, and just write down 3 things about a cold front and 3 things about a warm front. So when cooler air moves in, it forces warm air to move up quickly. So cool air forces warm air up. The rise in air forms cumulus clouds along the steep boundary. Heavy precipitation or rain often falls at a cold front. So heavy precipitation and that could be rain or snow. And then we'll write down one more thing. It says, notice that near this steep cold front, people on the ground might see a line of clouds over them just before the cool air arrives. Have you ever felt the temperature drop quickly as clouds move into your area? So, something with that cold front is clouds come in, cool temps. And then I don't know, I'm not much of an artist, so it wouldn't help me as much. But if it would help you, I would write down, I would try and draw this out so that when cold air comes in, it comes in and it brings the warm air up where we get those clouds coming in. Um, and then with warm front, we'll actually do these three together. At warm fronts, warmer air moves against cooler air. The warmer air gradually rises above the cooler air. The clouds of a warm front often move more slowly and cause longer periods of precipitation than cold fronts. So a warm front is going to move slowly. And I also saw that it was less precipitation. And then down here we see, notice that near a warm front, people on the ground might see high clouds form above them before they feel the warm air. So that would be something that also is high clouds. And then we keep going on, and if it would help, like I said, it wouldn't help me, but if this is something that you think might help you, is that the warm air goes up and causes the cold air out, whereas on that cold front, the cold air comes in and sends the warm air up. So we're going to be continuing, like I said, this whole chapter is on the weather and how these masses, the air masses, those fronts are going to create some crazy, crazy weather. So tomorrow we're going to be looking at the different types of severe weather and how these types of fronts cause this weather. So what I would like you to do is you can go ahead, your notes should be all finished, and then we are going to jump right into our worksheet for today. Make sure that your name is on. And then first part, it says a boundary between two air masses. If you are looking at your notes, it says a boundary between two air masses. Right away I see that that is a front. And I just want to make sure it makes sense. But I also then have an air mass, and I can look at my notes again, and it says an air mass is a large body of air with similar properties. A large body of air with similar properties, so I can get that down. And then moving on, we've just got completing each sentence. It says the most important properties of an air mass are its blank and amount of water vapor. I remember in my notes, the most important properties are temperature and amount of water vapor. So I know that it is the temperature. Air masses move because of what? This is one. Wind causes air masses to move. So air masses move because of winds. Number 5, a maritime tropical air mass, I just want to have this out, is warm and blank, either dry or humid. Maritime tropical is warm and humid, so I know that it is humid. I'm going to have you have you do these three on your own. And then on number 9, use the back side of your notes to help you. It's asking you for what ways cold fronts differ from warm fronts. So I'd like you to come up with 2 ways that they are different from each other and complete that. And then you're going to be all set to go for lesson 2.